Hello first benchers, happy to have you in this session to discuss on a topic, microservices in a nutshell. Before going into our topic, say hi to Wizzy and Bookman. They're going to be your fellow first benchers. Let's start with a quote from Simon Brown. If people cannot build monoliths properly, they will be having hard time building proper microservices. For those who are wondering what is microservices and where to start, this video will give you a quick introduction. Throughout the video, we will be going over some analogies, sample applications, and some concepts around microservices. With that, let's start our discussion. Some of the items we will explore in this video: story of Bob and Steve, an analogy to explain monolith and microservices principle applied in real world. What is a monolithic architecture? Under this, we will design a sample application on a whiteboard. We will list out some challenges with monolithic architecture, and then we will see what is a microservices architecture, and then microservices architecture in essence. Under that, we will see how microservices communicate among each other, and we will go over how to convert a monolith into microservices under the section breaking a monolith. So that will be a whiteboard session too. And then we will look at some challenges and complexities around microservices, and finally a quiz. Story of Bob and Steve. Bob and Steve are shipping heads in a famous shipping company. One day, their supervisor asked them to ship a microwind turbine. Microwind turbine is not a big one. It can power a home or a small manufacturing unit. Bob and Steve readily accepted the job. Bob on day one, along with his co-workers, assembled the turbine and loaded the assembled turbine on his 18-wheeler truck and reached the destination on day 2. There he installed the turbine, and then he went home and had dinner with his family. Steve, along with his other colleagues, on day 1 took 4 semi-trucks and loaded the parts of turbines such as tower, blades, tail, and generator on each truck and shipped it. And on day 2, at the destination, he had some co-workers and contractors assemble all the parts and install the turbine, and he went home happily. Their company was very happy with their work, and they gave the second assignment with the same shipping item. Bob repeated his previous process. He assembled the parts on day 1, loaded onto his 18-wheeler truck, and installed at the destination on second day. Steve also repeated his previous process by putting the parts on 4 semi-trucks on day 1. But this time, Steve had a surprise after reaching the destination. His assembling guys didn't show up. The job got delayed for 2 more days. Finally, on day 4, he got his job done. On the following week, their company ordered them to ship a mid-range wind turbine. Bob and Steve had some ideas. So Steve, as usual, split the turbine components into 4 parts. But this time, he used 4 18-wheeler trucks, and he had it assembled at the destination and got the job done. Bob, like usual, he tried to assemble and load the turbine first. He realized that he needed more manpower, so he had to hire some new contractors. He had attached 3 more 18-wheelers in sequence to hold the turbine. Along the way, he started to list out some risks related to transportation compliance, number of engines needed to pull this huge load. Eventually, he got some clearance and had the job done. End of story. So this story should give some food for your thought. With that, let's go to our next section. In this section, let's discuss on what is monolith. So why do you need to learn about monolith? Aren't we supposed to learn microservices? Well, it is important to understand monolithic architecture because it is the basis for microservices architecture. Each microservices by itself is implemented according to monolithic architecture. So monolith in this context is defined as composed all in one piece. So it is a design approach where one application encompasses several tightly coupled functions. So let me remind you again on this code. If people cannot build monoliths properly, they will be having a hard time building proper microservices. Oh, Vizzy, there you are. Go ahead. Is Bob the monolith guy? Good that you remembered the story from the previous section. Yes, you're right. Bob followed monolithic architecture. In a typical enterprise application, we will have three layers: presentation layer, business layer, and data access layer. Presentation layer is what is being seen on the browser as a UI elements loaded with functionalities to make HTTP request from server. Business layer is where the domain-specific logic is written. Example, authorizing a user, placing an order, and such. Data access layer in this case is a logic that can interact with database or a message broker. So in monolithic architecture, developers use a single code base for all these layers and bundle up as a single application. Many times, logical components corresponding to different functional areas are all written and bundled up as one huge ball. We will go over an example in the next section. So benefit with this approach is the single application having multiple functional codes bundled up in one single code base. It is simple to develop, test, and deploy to some extent. So scaling a monolith follows the x-axis scaling on scale cube model. We will also see what is scale cube model in a bit. So here x-axis scale means running multiple copies of instances behind the load balancer to handle the traffic. Our whiteboard session, let's pick an example. Here, let's pick library management system. So under that, we will be having some functional modules. To name a few, we can say login module, library card management, searching the book. For that, we will be needing a book profile management, and then to check the availability, and then users lending profile, transaction management to check out and check in the book, and to send e-receipts. With that, let's get on the whiteboard. The architecture example, we picked up library management system. So here's our user who is logging into our system. For that, we will need a login module. Login module is going to use user profile module, where all the information about the user is stored. And then we will also need library card module, where user's library card can be verified for the expiration and validity. So these components are tied together, and once the login is successful, user can search on the book. For search, we are going to be depending on book profile module and the availability module. So once the user searches the book, user can transact on it. So let's look at the scenario of checkout. So this can be used for check-in also. So once the book has been checked out, the availability count for that book has to be reduced, and for that user, total number of books checked out should be updated. After the successful checkout, user will require a receipt. For that, we are going to use e-receipt module. So when you look at this entire picture, you can see that all these components are tied together. So from a development standpoint, every single component is running in one single code base. And let's say over the period of time, we'll be having multiple users logging at the same time, and this one application cannot cater that much need. So based on our x-axis scaling, we will need a multiple instance of this application running in parallel behind the load balancer. So with that, let's conclude our whiteboard session and move on to find out what are all the challenges with monolithic architecture. Some of the challenges with monolithic architecture. First of all, is there a challenge with this architecture? Yes, any design will have its challenges and trade-offs. Here in this architecture, we are composing multiple functional domains in one large code base. Let me ask you to take a pause and think about improving and maintaining this application over a 5-year period of time. So think about new functionalities getting added. Along the way, new business analysts write a new requirement. So new developers get their head around updating the existing code. Sometimes it's like moving to a new database because CFO of your company asked you to do so to cut down cost on licenses. Or some my way or highway kind of architect wants to update your existing language from Java to Scala. So after some thought, here are some challenges that can be faced by monolithic architecture. Maintenance. When application grows larger, it becomes harder to make changes fast and accurate under pressure and unclear requirements. Monolithic applications are implemented using some known development stack. Upgrading the application to or change to a new stack will take a lot of effort. In a scaled environment, on sensing slowness, spinning a new instance will take a lot of time. Challenging to scale when different modules have conflicting resource requirements. Let's say one component could be CPU intensive and another could be memory intensive. And then think about reliability. One misbehaving component can bring down the entire application. So when the application grows, it may end up requiring a large team to add more functionalities. So as the time flies, many developers, consultants could create a difficult scenario to make a simple change, considering the tight dependencies among the modules. So that wraps up our discussion on monolithic architecture. So with this understanding, let's move on to the next section about microservices architecture. In the core topic, microservices architecture. So what is microservices architecture? So loosely stated, microservices architecture is a disassembled monolith into a set of independent services that are developed, deployed, and maintained separately. So let's think about this. We have a monolithic code, and then let's say in the monolithic application code base we have 1000 classes. So can we just pick up 100 classes and then group it into 10 modules and then run each module as a separate service? Is that a microservice? No. Or can we look at a class and identify the functions or methods and then run that method as a separate microservices? Is that a microservice? No. So what is a microservices then? So it's an independent service that is domain specific or grouping closely related functions specific. So if you think of our library management system, so we had multiple boxes in components, I would say. It's a login module or a search module or a transaction module. So those modules, if you just separate that out and then run that as a separate service, then that can be called as a microservice. Oh, Vizzy got a question. Go ahead, Vizzy. Is Steve the microservices guy? Okay, she still remembers the analogy that we discussed in the beginning of this video, the Bob and Steve, right? So Steve is certainly a microservices guy. If you look at the story, Steve disassembled his parts and then put it into multiple semi-trucks, and then he assembled the parts at the destination. So certainly Steve followed microservices approach. Good, Vizzy. So with that, let's move on to the next section, microservices architecture in essence. Since a microservice architecture, each service can have its own tech stack for development, and it can be developed by one single team. And multiple services can communicate among each other without any interdependent libraries, and they are all loosely coupled. So how to achieve that microservices communication? We can look at that in a bit. So each service can scale independently. Like monolith, microservices can also scale based on x-axis scaling on a scale cube model. On top of that, it can do y-axis and z-axis scaling. So to understand scale cube model, let's look at this perception. So this is a cube. Let's assume that this is a scale cube and it has got a y-axis, x-axis and z-axis. So x-axis scaling is nothing but running multiple copies of an application behind a load balancer. And y-axis scaling is where a huge application is decomposed into multiple services, which each service is like having a closely related functions, or we can say that it's decomposed based on a noun or a verb specific. So noun specific decomposition can be thought of in our library management system as a user management service, book management service, and such. When we think of the verb specific decomposition, we could think of like an entire use case, like checkout service, user validation service. And let's see what is z-axis scaling. So imagine there is a huge master table and we wanted to run two services on top of it. So each service can target only like a subset of the master table, and it can be scaled into another service by targeting another subset. So by that way, z-axis scaling is achieved. And communicate among each other in two different ways: a synchronous way and an asynchronous way. In a synchronous way of communication, where an application makes a call to a service and waits for its response, and then the app will execute the logic based on that. In asynchronous communication, an application makes a call to a service and does not wait for the response, or the response will be picked up later to close the loop. So in an elastic auto-scaling environment, microservices will require a service registry mechanism to find and communicate among each other. Bookman has a question. What is elastic auto-scaling environment? So in an environment where the service call load very rapidly, service instances will be scaled out or scaled in, which means the service instance count will be increased automatically when the load increases, and instances will get killed when the load decreases. And when the multiple instances are running, we may need an automatic leader instance selection, which will require a microservices orchestration. Okay, Vizik has a question. What is a leader instance? A leader instance is a single point of contact for service delivery. For example, in an environment where multiple instances serves the same functionality, a leader instance would make sure certain calls won't be made twice to prevent the duplicate response. I hope it makes it clear now. Let's move on to the next section. Break a monolith into microservices. So let's go back to our example, library management system. So that's a huge monolith that we designed in our previous sections. So now, how to break that? So we can break that into login service, library record management, search book service. Under that, we can have two different services: book profile management service and availability service. And we could have user lending profile service, transaction management service, and send e-receipts service. So with that, let's jump into our whiteboard session. This section, let's focus on how to break the monolith into a microservices architecture. For that, we will take an example of library management system that we have designed earlier as a monolith. So above, a little picture shows the reference to our previous monolithic architecture. So let's break it into microservices. So there are multiple ways we could do it. Let's focus on a very simple one. So here is our user. The user is going to talk to our library management system. So for that, let's have an API gateway. So API gateway should have a reference to all our existing endpoints for our services. The first thing is login service. this is one microservices, written and maintained by one team. There could be search service, transaction service, so again we could have another API gateway. We could have book management service, availability service, could have a message broker, and then e-receipts service. So user could log in, and login is going to verify against its own little database. Remember, this is a microservices and it can have its own database. It doesn't have to be going into a centralized database. Whichever way it's easier, or we could take a trade-off where it's going to be cheaper and feasible. It could also go to an Active Directory to verify the login, or it could also talk to another service federated to do the verification of the person who is logging in. And once the user is successful, user can search, and search service is going to talk to API gateway, internal API gateway, to list the book and its availability. Once the book is successfully searched, the user could try to get the lending profile service. To find if the person is valid with proper library card, and once that is successful, user can transact on that to check out the book. And once the book has been checked out successfully, the availability count for that book is getting updated through the availability service, and transaction service is talking to API gateway to do that. Once that is successful, information can be put into a topic or message broker on a message broker's system, and from there e-receipts service can pick that message and send it to a printer or send it to an email or whatever the way possible to get the receipts to the user. Now this is how the individual components can be split. Remember, this is microservices. Each one is a microservice and can be maintained by a separate team, and it can be modified individually without touching the entire code. So it's all living and having its own code base, and every single services can be running in multiple different operating systems, or it can have its own environment, and it can scale independently. So let's say login could have 3 instances. Since search is like more often, it can have like 100 instances. Transaction service again could be very active, and it could have 50 instances. And lending profile, let's say we have 3 instances or 5 instances or so. Each one could be having its own database. Same thing with book service, it can have its own database, multiple instances of service. And now to make the receipt service as durable, can be durable at the message broker level, or can also make it durable here. And let's say some other team wants to access our library management system to find out how many books are available in the library management system. Let's say this is a library, and there is also in our company we are giving out a flyer saying that, hey, these are all available books in our library. Um, Anybody can choose it at different times and when it is getting available or when it has been returned. So that is like a forecast service written by some other application. So they could also talk to this availability service through this gateway. So let's say this is outside our boundary. Another application is talking to the library management system. So that's how a typical monolith can be broken down into microservices architecture. So this is one way we could do it. There are many different ways we can design this. So with that, we can conclude this section, and then we can move on to the next section of finding out the challenges with microservices and complexities with microservices. In an elastic auto-scaling environment, service instances might change their IP dynamically and will require new server for service registry, which keeps track of where the services live with what IP. Orchestration is additional complexity to keep all scaled services synced up and also for electing leader instance. Depending on how granular the service is broken down, the calling service will need to collect output from all required services. That's not the same case with the monolith, where it is a huge one application and the requirements can be fulfilled by just one call. Since each services are dispersed and intercommunication occurs among services, when a defect is found, it is very tough to assign responsibility to specific service teams. So this will also require a merging and centralizing of all the logs from each individual services for troubleshooting. Smaller pieces means the microservices team may not be having a bigger picture of the application. As the microservices grow in numbers, communication and coordination with multiple teams for requirements will be a challenge. When each service are developed in a variety of tech stacks, hiring and training on each tech stack is a challenge when original development team is not there anymore. If one microservice is slow due to network latency or I/O resources or some firewall changes, then it will have a cascading effect on all the dependent microservices. So that concludes some list of challenges with microservices architecture. So every project has to strike the right balance on deciding between monolith or microservices architecture. So with that, we can conclude this discussion about microservices in a nutshell. If you have time, you can go over the quiz in the next section. For more practice quizzes, please visit www.firstbenchacademy.com. The link will be provided in the video description as well. So thank you for watching this video. For more videos on microservices or on any other topic, please subscribe to our channel, First Bench Academy. Thank you.